Hi, my name is Zahra Movahedi Nia, and I'm a postdoc at York University at Academic Laboratory, which stands for Africa Canada Artificial Intelligence and Data Innovation Consortium. And my background is computer engineering, and my field of interest is machine learning, data analytics, and natural language processing. So in this work, we have used social media and particularly Twitter to trace the unemployment rate of South Africa during the COVID-19 pandemic. As we know, the labor market has been hard hit by the COVID-19 pandemic. According to the International Labor Organization, in 2020, the global unemployment rate increased by 5.4%, and as a result, the global labor income decreased by 8.3%, and the global GDP decreased by 4.4%. So this shows that unemployment is an important factor of the economy that affects all the other aspects and all the other parts of the economy. And unemployment rate is an important measurement to different companies, to small businesses, and to insurance companies for um, understanding the economic activities and for balancing their cost and income. And also, unemployment rate is an important indicator to policymakers for measuring social stability and informing policy. Currently, unemployment rate is mostly measured using census taking methods, which are very expensive and time consuming. They require a lot of manpower and administrative personnel, and also they face many different difficulties and obstacles, such as low public cooperation and privacy concerns. And so due to these difficulties, census taking is mostly done on seasonal or annual basis. For example, in South Africa, it is done on seasonal basis, and the results are ready and reported with several months of delay. So this may not be enough for situations such as COVID-19 pandemic. Therefore, in this work, we have proposed an alternative way for measuring unemployment rate, and that is using social media. Because retrieving data from social media is fast, it could be done in real time and with a lot less effort, like with several lines of code, data could be available. And therefore, it could be done on a more frequent basis, like on monthly basis, rather than seasonal or annual basis. And then it could be done in real time, with like several hours of delay at maximum. So our methodology includes three steps. And the first step, we gather our Twitter dataset. And the second step, we perform sentiment analysis. And finally, in the third step, we use our dataset for nowcasting unemployment rate. So using some initial keywords, we gather a Twitter dataset and we compare it with the actual unemployment rate. And so we select those keywords that have a correlation higher than zero point 0.4 with the unemployment rate. And we found the sentiment of the tweets. And we also have the volume of the tweets. Uh, we merge these two data sets and we standardize it. And then we use it to nowcast unemployment rate using principal component regression. So, using some initial keywords related to unemployment, more than 2 million tweets were gathered, and this was done using the Twitter API Academic Researcher account. All the tweets were geotagged and they were posted from South Africa, so the tweets were cleaned. URLs, mentions, and punctuations were removed. After cleaning the tweets, some of them became null, they were removed. And then the tweets that were posted by bots were identified and removed. And the final dataset was divided into two parts, before COVID-19 pandemic and during COVID-19 pandemic. The reason to this was that before COVID-19 pandemic, the unemployment rate was pretty stable. But during COVID-19 pandemic, due to several rounds of lockdowns, it had many fluctuations, and this seasonal unemployment rate was not able to capture these peaks. So it needed to be interpolated. And we used Google Mobility Index to interpolate the unemployment rate during the COVID-19 pandemic because according to International Labor Organization, Mobility Index could be used to estimate unemployment rate. So Google Mobility Index is an indicator, is a measurement that is consisted of 6 different indicators. So these indicators are associated to different locations: retail, grocery, parks, transit, workplaces, and residential places. So basically, the movement of people in these different locations is compared with a baseline. If people have moved more compared to the baseline, the value is positive, and if they have moved less, the value is negative. And all of these indicators are positively correlated with each other, except for residential places, which is negatively correlated with the rest of the indicators. So, the reason is that during the lockdowns, people stay at home and move around their residential places, and they move less in the other locations. And on the other hand, after the lockdowns, when the lockdowns are lifted, they go to other locations and movements increase, and other locations and decrease in the residential places. So therefore, the residential indicator has a negative correlation with the rest of the indicators. So we took an average over all the indicators except for the residential places. And then we fitted the result to the actual unemployment rate using linear regression, and we evaluated the fit using a symmetric MAPE. So symmetric MAPE is a value between 0 and 2, and any value lower than 0.1 shows that we have a good fit. So here the symmetric MAPE was 0.05, which indicated that the Google Mobility Index was very well fitted to the actual unemployment rate. So these are the keywords that we use to gather our Twitter data set. So the volume of the tweets gathered using these keywords over time was compared with the seasonal unemployment rate for before COVID-19 pandemic and the interpolated monthly unemployment rate during the COVID-19 pandemic. And any keyword that the correlation for before and during COVID-19 pandemic was higher than 0.4 was selected. So in economy, 0.4 to 0.7 is considered a moderate correlation, and higher than 0.7, it is considered strong correlation. So basically, we gathered those tweets that their volume had a moderate to strong correlation to the unemployment rate, and we did this to avoid overfitting. So our data set, our final data set included slightly more than 1 million tweets. And this is a word cloud of our data set. So the dominant words are related to unemployment and finance. And our data set had a correlation of 0.53 with the unemployment rate before COVID-19 pandemic and 0.9 during the COVID-19 pandemic. Then we perform sentiment analysis. So sentiment analysis is a natural language processing procedure which classifies text based on its sentiment into 3 classes of positive, neutral, and negative. And we perform sentiment analysis using a pre-trained model which was fine-tuned on BERT, Cardiff NLP. We manually labeled 200 tweets of our dataset, and we performed the sentiment analysis model on the labeled dataset, and we found that we found that this model has 69% accuracy on our data. So most of the tweets had a neutral sentiment. And the number of tweets with negative sentiment was significantly higher than those with positive sentiment, and that was expected because the dataset is on unemployment. Another interesting thing we found was that the number of tweets with negative sentiment during COVID-19 is uh, uh, higher than the number of tweets with negative sentiments before COVID-19 pandemic. And the number of tweets with neutral and positive sentiments during COVID-19 is lower compared to before COVID-19 pandemic. Another important factor that we used was the sentiment score. So sentiment score is a value between -1 and 1. Negative, neutral, and positive sentiments have a score close to -1, 0, and 1, respectively. And we found that the sum of the sentiment scores of the tweets are over time are negatively correlated with the unemployment rate, and this was expected because as the unemployment rate increases, people become dissatisfied and their tweets become more negative and the sentiment score decreases. So it was expected that the sentiment scores have a negative correlation with the unemployment rate. So basically, the sentiment scores had a correlation of -0.6 with the unemployment rate before the COVID-19 pandemic and -0.86 for during COVID-19 pandemic. So basically, we had the sentiment of the tweets and the volume of the tweets, and we wanted to use that for nowcasting the unemployment rate. So we had different keywords, and each of these keywords gave a data set of tweets, which their volume we considered it a different independent variable, and then we had the sentiment of the tweets, which had a negative correlation with the unemployment rate. Therefore, it was inverted. And so these were our independent variables, and then our dependent variable was the unemployment rate. So the independent variables were standardized, and then principal component regression was used to estimate the unemployment rate uh, using the independent variables. So basically, principal component analysis was performed on the independent variables, and then using multiple linear regression, unemployment rate was nowcast. After performing principal component analysis uh, on our independent variables, we found that the first principal component had more than 80% of the explained variance. However, when we used a different number of the principal components for nowcasting the unemployment rate, we found that the minimum error is obtained when we use the first 5 principal components. So the first 5 principal components were used, and then multiple regression was performed on them. And so basically, 2/3 of the dataset was used for training the model and 1/3 for testing. And we could see here that the estimated values are very well correlated with the actual unemployment rate values, and that our model has a low root mean square error MAPE and symmetric MAPE, and an R squared score of 0.92. And then we used the data before COVID-19 pandemic to train the model. And then we used the model to nowcast the unemployment rate during the COVID-19 pandemic. And we can see that the estimated values very closely follows the actual unemployment rate. So we didn't stop here. We went further and we tried to nowcast unemployment rate of each of the provinces of South Africa. So we found that our data set has about uh, 100,000 users. So we wanted to know the dominant province of each user where the user is settled because um, it is very common that people tweet while they are traveling, and we didn't want it. Uh, we wanted to consider the original location of the users for each tweet. So for each user, we found the provinces that he had posted the tweets from uh, for 1 year, and then we found the dominant province, and we took that uh, as the primary province of that user, where that user is settled. And so using this method, we found the province of each tweet. And for each province, we performed principal component regression to estimate the unemployment rate of that province. And we got outstanding to reasonable results for all of the provinces. Like for Eastern Cape, the R squared score is 0.77. For Gauteng, it's 0.87. For KwaZulu-Natal, it's 80.62. So for Gauteng, we found outstanding results. We used 2/3 of the data set to train the model and one third to estimate it, and we found that the estimated values very well correlates with the actual unemployment rate, and the root mean square error MAPE and symmetric MAPE is very low, and the R squared score is 0.87. And then we used the data that we had for before COVID-19 pandemic to train the model, and we used the trained model to estimate the unemployment rate during the COVID-19 pandemic, and we can see that the estimated values closely follows the actual unemployment rate. We did the same thing for KwaZulu-Natal, and we found outstanding results here as well. So we used 2/3 of the data set to train the model and 1/3 to test it. And we can see that the estimated values are very well correlated with the actual unemployment rate. The root mean square error MAPE and symmetric MAPE are very low, and the R squared score is 0.62. And then we trained the model using the data for before COVID-19 pandemic. And then we used it to now cast the unemployment rate during the COVID-19 pandemic. So here again, we can see that the estimated values closely follows the actual unemployment rate. So like all the other research that is done using social media, our work has some limitations too. First of all, only 15% of the population uses Twitter, and then Twitter users are mostly from certain ages, like from 18 to 29 years old, and only 3 to 5% of the tweets are geotagged. And then we only studied English tweets, but South Africa has 11 different official languages, but we were only able to analyze the English tweets. So we wanted to see how these limitations affect our data set. So we found that most of our data set is from Gauteng, KwaZulu-Natal, and Western Cape. So these three provinces are the industrial provinces of South Africa. And then we studied the relative population in each of the industries. of South Africa, and we found that in most of the industries, the population mostly comes from Gauteng, KwaZulu-Natal, and Western Cape. And only in three provinces the population comes from other, only in three industries the population comes from other provinces. But if we look at the actual population that are working in each of the industries, we can see that a very low portion of the population is working in these three industries, and most of the population are working in the other industries. This confirms that we are getting our data from the right people and from the right locations. Uh, we are getting the data from people who are in the industries and who are actually working. So this confirms that although there are some limitations to our data set, but it is coming from the right places. And also we studied the age groups, and we found that the people from working ages, like for example, from 15 to maybe 65 years old, they are mostly from Gauteng, KwaZulu-Natal, and Western Cape. And in other age groups, people are from other provinces. So again, this confirms that we are getting our data from the right people and from the right population. And also we studied the sentiment scores. So basically we found the average sentiment scores over time for urban and rural areas. Urban areas belong to Gauteng, KwaZulu-Natal, and Western Cape, and rural areas belong to other provinces. So we can see that before COVID-19 pandemic, these sentiment scores are very close to each other, but during COVID-19 pandemic, the sentiment score of urban areas is significantly lower than rural areas. So the reason to this is that uh, people that are actually working in the industries, they are mostly residing in urban areas, and so during the COVID-19 pandemic, they become very dissatisfied with the unemployment conditions, and their sentiments significantly uh, is significantly decreased, uh, and it is lower than rural areas. So this again confirms that we are getting the right data set because it all makes sense. So we are getting our data set from the right populations, and although there are limitations, but our data set is making sense, and it is following the trend that it should be following. So hopefully, our method will work in the long term. Especially because we have gathered data from uh, 2009, like since geotag tweets existed, and uh, the volume of the tweets and the sentiments had always correlated with the unemployment rate before COVID-19 and during COVID-19. So hopefully in the future they will keep on correlating, and hopefully this method can still be used for estimating unemployment rate in future and any disasters if they ever happen again. So as a contribution to future of our work, we can, in this work, we have used only text to nowcast unemployment rate, but we know that social media is rich with other content such as images and videos that can also be used to nowcast unemployment rate or other macroeconomic factors. Also, in this work, we have used social media to nowcast unemployment rate. Maybe heuristic methods could be proposed to forecast unemployment rate or other macroeconomic factors. And at the end, I'd like to thank the founders of this project, IDRC and CEDA. And I'd like to thank Academic and my supervisor, Professor Jude Kong for his great supervision.